A room stretches toward a landscape that seems almost limitless. The ceiling is high. The furniture looks small within the space. The floor runs across the room and ends at a wall that, at first glance, barely seems to exist. Instead of brick, stone, or concrete, there is glass. Enormous panels extend from floor to ceiling. Outside, the ocean fills the horizon. In another home, it might be a mountain, a forest, or the lights of a major city. The interior and the landscape seem to form a single space. This image has become a signature of luxury homes. But why? A conventional wall is cheaper, stronger, more private, and generally easier to insulate and climate control. Even so, the more luxurious a home appears, the more glass it tends to have. The explanation goes beyond aesthetics or the desire for natural light. Luxury homes often have enormous windows because their owners can afford four things that were historically rare: light, glass, technology, and a view. And this story begins in an era when even a small transparent pane was a display of power. Long before glass, an opening in a wall presents a problem. A home needs light, but it also needs to keep the outside world outside. The same opening that illuminates the interior also admits rain, wind, dust, insects, animals, and potential intruders. In cold regions, every opening allows heat to escape. In hot regions, it lets in solar radiation and heated air. During a storm, water passes through the opening. At night, it becomes a vulnerable point. The earliest solutions look nothing like modern windows. A wooden shutter can close the opening when the weather turns. Fabric, animal hides, latticework, and translucent materials reduce airflow, but they also block some of the light. In some places, thin sheets of worked horn provide diffused illumination. The interior becomes less dark, but the landscape remains almost entirely invisible. The logic is simple. The smaller the opening, the easier it is to control the interior environment. A home with thick walls and few openings retains its temperature more effectively, requires fewer moving components, and has fewer points where water can enter. Light is desirable, but its price is simply too high. For thousands of years, good residential architecture doesn't try to make the wall disappear. It tries to prevent the outdoors from passing through it. Glass begins to change that relationship, but very slowly. In the ancient world, different civilizations already know how to produce glass. The Romans use it for objects, vessels, mosaics, and even some windows. Excavations have uncovered fragments of architectural glass in villas, public buildings, and bath complexes. But that material is nothing like the panels we know today. The panes may be small, thick, irregular, and heavily distorted. Their surfaces contain ripples, bubbles, and variations in thickness. The window admits light, but it doesn't always offer a clear view. Someone looking through it can make out shapes, movement, and color. The landscape appears as though it were seen through frozen water. Even so, having glass in an opening provides an enormous advantage. Light can enter without allowing the wind to pass freely through the wall. The interior remains better protected, even in broad daylight. But producing this material requires fuel, raw materials, technical knowledge, and specialized labor. Making a large, uniform pane is even more difficult. The larger the piece, the greater the risk of breakage during manufacturing, transportation, or installation. That is why glass appears more readily in important public buildings and elite residences than in ordinary homes. The window begins to mark social status not because it is enormous, but simply because it exists. Even a small, irregular pane shows that the owner can afford something others must replace with wood, fabric, or an empty opening. Light begins to acquire a social class. During the Middle Ages, another obstacle limits the size of windows. The problem isn't just the glass, it's the wall. In many stone buildings, the walls support the weight of the floors and roof. Loads travel down through the masonry until they reach the ground. When a builder cuts an opening, part of that load path is interrupted. The larger the window, the less material remains to support the building. A small opening can be spanned by a lintel, a horizontal element placed above it to transfer weight to either side. Increasing the width requires larger stones, stronger timber, or another way to distribute the load. Arches offer a solution. Their components work primarily in compression, directing the weight toward the sides. In churches and cathedrals, arches, columns, and buttresses allow larger sections of the walls to be opened. A buttress is a mass built against the outside of a structure to resist its outward thrust. It absorbs forces that could deform or overturn the wall. As this system becomes more sophisticated, extraordinary openings can be filled with stained glass. These windows aren't merely sources of illumination. They transform light into narrative, color, and power, producing thousands of pieces of colored glass, joining them with framing and supporting the entire assembly within a monumental structure requires craftspeople, resources, and planning. The window becomes a work of architecture within the larger work, but the development of large religious openings doesn't automatically reach private homes. A cathedral can use its structure, resources, and scale to support enormous stained glass windows. An ordinary family still depends on simple walls, small openings, and inexpensive solutions. Castles and fortified residences face different priorities as well. Windows must provide light without compromising defense too severely. Thick walls and narrow openings preserve security and stability. Even when glass appears in elite homes, it remains expensive. Small panes must be assembled within divided frames. Every joint creates another visual line. Every pane can break. Every gap requires sealing. A wealthy home can admit more light, but it also becomes harder to heat. That contradiction follows the window for centuries. Palaces and great aristocratic residences transform the problem into spectacle. Facades become organized around sequences of aligned windows. Openings follow carefully chosen proportions. Floors create visual rhythms. Doors and windows are positioned along axes of symmetry. The window is no longer simply an answer to the need for illumination. It becomes part of the owner's public image. The more glass a facade contains, the greater the cost of manufacturing, transportation, installation, and maintenance. A residence filled with windows also loses more heat than one enclosed by thick walls. That means the owner has to pay twice. First, to purchase the glass. Then, to overcome the discomfort it creates. Fireplaces, fuel, curtains, tapestries, shutters, and maintenance crews all become part of the cost. Natural light improves inside grand halls, but the space can become bitterly cold in winter. For the elite, that expense also communicates power. A brightly lit gallery can host ceremonies, gatherings, and displays of artwork. Rows of windows across the facade show that the building isn't concerned only with conserving heat. The residence can afford to open its walls. Outside, formal gardens are designed to be seen from within. Axial paths, fountains, sculptures, and walkways become scenes framed by windows. Glass begins to connect two displays of wealth: the house and the land surrounding it. It isn't enough to own a large opening. You also need to own something worth seeing on the other side. In certain countries and historical periods, even the number of windows is directly connected to taxation and social status. In England, for example, a tax introduced in the late 17th century takes the number of windows in a building into account. Some owners go so far as to brick up openings to reduce their tax bill. Those blocked windows preserve an irony. Light is valuable enough to be taxed. In that world, a facade filled with glass reveals that its owner can afford the manufacturing, heating, maintenance, and, in some contexts, the very right to keep those windows open. The poor close their homes to retain heat. The rich open their walls to display power. But glass remains constrained by the way it is produced. Before modern industrial techniques, different processes create small or irregular panes. In some methods, glass is blown into forms that are later opened and flattened. In others, the molten material is worked into discs or sheets. These processes require skill and impose limits. The larger the desired pane, the harder it is to control its thickness. A minor defect can ruin hours of work. Once finished, the piece must survive poor roads, carts, ships, and handling without modern equipment. That is why many old windows are divided into small squares or diamond-shaped panes. The pattern isn't merely decorative. It allows a large opening to be filled with panes that craftspeople can actually produce and replace individually. If one piece breaks, the entire window doesn't have to be rebuilt. The appearance emerges from the limitation. Then come the 18th and 19th centuries, and the relationship between walls and glass begins to change rapidly. More efficient furnaces, mechanization, rolling, and other improvements make it possible to produce larger and increasingly uniform panes. Glass still requires energy and control, but its production is no longer governed solely by the pace of handcraft. At the same time, iron and steel enter architecture on a growing scale. This change is decisive because windows never depend solely on transparency. They depend on whatever supports the building around them. A massive wall combines several functions. It supports floors, carries the roof, encloses the interior, and contains the openings. Once metal frames begin carrying part of the structural load, the facade gains new freedom. Railroad stations cover enormous spaces with metal and glass. Greenhouses create luminous environments for plants. Exhibition halls display transparent structures that would be almost impossible to build with traditional walls. Retailers recognize another advantage. A large pane turns the facade into a display window. The interior no longer remains hidden. Merchandise can be arranged for people to see from the street, even when the business is closed. Glass begins to sell. In homes, larger windows improve illumination and connect interiors more closely with gardens. But the best solutions remain expensive. Glass may be more affordable than before, yet a large opening still requires structure, framing, weather seals, and skilled labor. The Industrial Revolution lowers the price of transparency. It doesn't eliminate its hierarchy. In the 20th century, reinforced concrete and steel framing separate functions that had remained combined for centuries. Columns and beams now support the building. The exterior wall no longer has to carry every floor on its own. In many projects, it becomes little more than an enclosure between the interior and the weather. That changes everything. A large opening is simply a greater distance between supports. To span it, a beam receives the loads above and transfers them to columns positioned at either side. When this system is properly engineered, the space below can be filled with glass. The lightweight facade emerges, an enclosure that weighs and behaves differently from a massive wall. In larger buildings, the curtain wall acts as an exterior skin attached to the primary structure. It doesn't support the floors, but it must resist its own weight, wind pressure, and water intrusion. Modern architects explore this freedom. Ribbon windows stretch horizontally across facades. Open floor plans reduce dependence on interior load-bearing walls. Cantilevers project parts of the building beyond their supports. Expanses of glass occupy areas that once required masonry. Architecture begins to associate large windows with light, ventilation, hygiene, and contact with nature. The promise seems democratic. If walls are no longer essential to supporting the building, every home could receive more light. But technology doesn't erase the market. The largest panels, thinnest frames, most precise mechanisms, and highest-performing glass remain concentrated in expensive construction. And the most desirable landscapes aren't distributed equally either. Transparency becomes modern. Privilege remains. There is a technical reason for this. An enormous window isn't simply an ordinary window enlarged. As the panel grows, its weight increases. Glass appears visually light because it is transparent, but it remains a dense material. A single oversized pane can weigh hundreds of pounds. That weight must leave the factory, enter a truck, travel through streets, and reach the construction site without an edge striking a hard surface. On difficult-to-access sites, the panel may have to be lifted by crane. Crews use mechanical suction cups or vacuum lifting equipment to hold the pane. The glass is tilted, raised, and moved slowly toward the opening. An error of just a few millimeters can prevent it from fitting. It looks weightless, but it arrives at the house as an industrial load. Wind creates another problem. A gust presses against the entire surface. The larger the area, the greater the total force that may be applied to the panel. Glass deflects, even when that movement is almost invisible. If its thickness, supports, or mounting system are inadequate, the pane can break. Engineers size the panel according to its dimensions: thickness, location, building height, and exposure to wind. A home sheltered by surrounding buildings faces different conditions from a residence on a mountaintop or overlooking the ocean. The edge requires special attention. Minor damage, scratches, or imperfections can concentrate stress. That is why manufacturing, transporting, and installing a large pane demands far greater control than placing a small sheet of glass in an ordinary window. The type of glass also changes according to the risk. Tempered glass undergoes heat treatment to increase its strength. When it breaks, it tends to shatter into smaller pieces, reducing certain hazards compared with large, sharp shards. Laminated glass combines two or more sheets with an interlayer. If the glass breaks, this film helps hold the fragments together. It is as though the panel remains attached to a transparent skin. Depending on the application, both principles can be combined. But solving the safety problem doesn't solve the comfort problem. A well-insulated wall restricts heat transfer. Even sophisticated glass generally transmits more energy than a high-performance opaque wall. In winter, the interior surface of the pane may become colder. The human body radiates heat toward that surface, making a person feel uncomfortable even when the air in the room seems warm. In summer, solar radiation passes through the window and heats the floors, furniture, and walls. Those elements release energy back into the room. The space becomes a greenhouse. This is where double and triple pane glazing enters the picture. 2 or 3 sheets of glass are separated by sealed spaces. The still air between them reduces heat transfer. In higher performance systems, those spaces are filled with gases such as argon, which reduce it even further. Low emissivity coatings, known as low-E coatings, add another layer of defense. These metallic or metal oxide layers are so thin that they remain virtually invisible. They control thermal radiation without blocking all visible light. In cold climates, certain configurations can take advantage of some solar heat. In hot climates, others reduce the transmission of infrared radiation, which heats the interior without contributing to visible illumination in the same way. There is no perfect glass for every location. Orientation changes everything. A facade facing intense afternoon sun can overheat. The same amount of glass, facing another direction and protected by shade, behaves completely differently. Eaves and brise soleil block radiation before it reaches the pane. A brise soleil is an exterior element designed to block sunlight from specific angles. Depending on the latitude and orientation, its position can allow low winter sun to enter while blocking the higher summer sun. Automated blinds respond to the time of day or to sensors. Curtains control glare and privacy. Trees provide seasonal shade. Ventilation removes some of the accumulated heat. The frame also takes part in the battle. Metal profiles conduct heat easily. To interrupt that path, high-performance systems use a thermal break, a strip of less conductive materials separating the interior portion from the exterior. Without that interruption, heat travels through the metal as though it had found a bridge. The joints must accommodate small movements. Glass, metal, wood, and concrete expand at different rates as temperatures change. If everything is rigidly fixed, the components can press against one another. Flexible sealants accommodate some of this movement. Internal channels drain water to the exterior. Profiles create successive barriers against wind and rain. A large window represents more than the price of the glass. It represents the price of every system required to correct the problems it creates. And there is still an invisible expense: climate control. When a transparent wall allows significant heat gains or losses, mechanical systems must compensate. Heating works harder in winter. Air conditioning removes heat in summer. In a luxury residence, that effort may be concealed behind quiet equipment, radiant floors, sensors, and automated controls. The occupant sees only the landscape and feels a constant temperature. The engineering disappears so the window can appear simple. The greater the transparency, the greater the cost of maintaining that illusion may become. But technology alone cannot explain why glass remains so desirable. The other half of the answer lies outside. A luxury property doesn't sell only its square footage. It sells the landscape. A penthouse overlooking an urban skyline turns lights and buildings into private scenery. An oceanfront home draws the sea into the living room. A residence on a hillside frames the valley. A property surrounded by forest allows its occupants to watch the trees without leaving the comfort of the interior. The window acts as an architectural frame. It selects what will be seen and excludes everything else. It can direct the eye toward a mountain, conceal a street, or turn a solitary tree into the center of the composition. The rarer the view, the more valuable it becomes to open the wall toward it. That explains why glass appears so prominently in penthouses, elevated lots, lakefront properties, and coastal areas. The panel doesn't create the landscape, but it turns the landscape into a permanent part of the real estate experience. There is also a question of control. A home close to the sidewalk is exposed to people's eyes, noise, and movement. Enormous windows can expose the residents. Curtains remain closed, and the transparency promised by the design disappears. A residence on a large property has distance. Gardens, walls, vegetation, and changes in elevation filter outside views. The occupant can afford exposure because privacy has already been purchased around the house. So the window reveals two kinds of wealth: the wealth of the building and the wealth of the empty space surrounding it. A glass wall facing another wall nearby offers little advantage. The same surface overlooking a broad property becomes a luxury. The view also requires maintenance. The larger the panel, the more visible dust, rain marks, salt, and fingerprints become. Tall or hard-to-reach facades may require specialized cleaning equipment. Oversized sliding doors require precise tracks and hardware capable of moving heavy panels. Motorized systems conceal the effort. but they increase the number of components that must remain operational. More transparency means more surface to clean, seal, adjust, and replace. Then comes the reversal. The enormous window begins as a display of wealth, but it can end as a display of waste. In poorly oriented projects, the glass receives excessive sunlight and forces the climate control system to run continuously. Curtains remain closed for much of the day. The owner pays for a transparent facade and then pays again to hide it. Reflections can create glare inside and affect neighboring buildings. At night, transparency turns a private room into a display case. Blinds and window films have to restore the privacy that was lost. Birds face another danger. They may not perceive glass as a barrier. Reflections of trees, sky, and vegetation appear to continue the surrounding environment. Large transparent or mirrored surfaces increase the risk under certain conditions. Exterior treatments, visible patterns, screens, and glass designed to be detectable by birds help reduce collisions. Once again, the solution requires recognizing that transparency to humans can mean invisibility to other animals. More glass, then, doesn't automatically mean better architecture. A smaller, well-positioned opening can provide enough light, frame a specific view, and reduce energy consumption. An opaque wall can block the sun, provide space for furniture, and create privacy. In some climates, shade is more valuable than transparency. In others, capturing solar radiation during part of the year may be beneficial. True sophistication doesn't lie in eliminating walls indiscriminately. It lies in knowing where to open them and where to remain enclosed. Contemporary architects try to balance these forces with increasingly advanced technologies. Electrochromic glass changes tint when an electric current is applied. Instead of relying only on curtains, the panel itself controls some of the light and solar heat. Kinetic facades change throughout the day. Shading elements open, rotate, or close. Sensors monitor light levels, temperature, and wind. Large sliding doors disappear into walls and connect living rooms to terraces. Retractable panels transform the facade in minutes. Automated systems move doors that would otherwise be too heavy to operate comfortably. Technology makes it possible to manufacture panels that are larger, safer, and more energy efficient. But the contemporary question is no longer simply whether we can build a glass wall. The question is whether we should. A window facing a rare landscape may justify the necessary structure and solar control. Another, oriented toward a street with no privacy, may remain covered for years. A sophisticated panel may reduce energy consumption compared with older glass. Even so, a well-insulated opaque wall often conserves more energy. The design must determine what transparency actually provides. Light is not the same as a view. A high window can bring daylight deep into a room without exposing its occupants. A panoramic window can offer a magnificent landscape while creating glare. A glazed door can improve ventilation when open, although the glass allows no airflow when closed. Status is not the same as comfort either. A facade that looks impressive in photographs may produce an interior that is difficult to use. Furniture must be kept out of direct sunlight. Artwork can fade. Screens reflect the light. Residents turn to curtains. Good architecture must continue working after the camera is gone. We return to the residence from the beginning. The ceiling remains high. The floor still ends before the ocean. The glass wall remains nearly invisible. Now, however, it seems much heavier. Those panels contain centuries of evolution. Small openings that once admitted rain and wind. Ancient panes, thick and distorted. Stained glass supported by monumental structures. Palace windows that wasted heat to display power. Then come industrial furnaces, rolling, metal frames, reinforced concrete, and lightweight facades. Glass grows larger. The wall loses its structural role. Cranes lift panels weighing hundreds of pounds. Microscopic coatings control radiation. Invisible gases reduce heat transfer. Outside, the landscape completes the value. Luxury homes don't necessarily have enormous windows, and enormous windows don't create wealth on their own. But the association remains because opening a large portion of a wall without sacrificing stability, safety, and comfort is still expensive. The owner isn't paying only for the glass. They are paying for the beams spanning the opening, the frame resisting the wind, the seals keeping the water out, the coating controlling the sun, the climate control system stabilizing the interior, the cleaning, the automation, the privacy, and they are paying for whatever appears on the other side. The large window brings light, glass, technology, and a view together in a single transparent surface. It looks like an absence. In reality, it concentrates an enormous amount of engineering. For centuries, wealth meant building stronger walls. Today, it often means being able to make them disappear. And if the very absence of a wall conceals a story this complex, follow the channel to discover the other invisible decisions that transformed the architecture of the homes we live in.